Hello everyone, I am Sishan Kalim. I belongs to computer engineering department and at the same time affiliated with IRC SML. So today I am going to present a talk. The title of a talk is When Quantum Meets the Sky and Smarter Drone Trajectories. So you can imagine that suddenly an earthquake or flood or any disaster occur. The whole network is lost, communication, no one can communicate with each other, and then to overcome this situation, you can imagine a fleet of drones flying in the sky and instantly forming a wireless networks and connecting rescuers, hospitals, and survivors. But here is the challenge. Challenge is each drone can fly in thousands of possible directions and heights. Drone can fly at this height, can hide this height, this direction, left, right, front, backward. Where to place the drone? Multiple drones are there. So this is kind of a network where different types of drones can be possibly deployed. So one drone has a purpose of sensing, other drone can have a purpose of communication, and so on. So the multiple types of drones as well, different heights as well, challenges are there. So that's where our work comes in. So we make drones think faster and coordinate smarter by using the ideas borrowed from quantum physics. So what is the novelty? The novelty in our work is that we have designed a quantum-inspired graph condensation method, which drastically reduces the search space. For example, in low altitude economy networks, search space matters a lot. If you have a huge search space, you have to search each point and try to find the optimal point. So to overcome this, we propose the quantum-inspired state reduction approach. So here we use the graph condensation method driven by quantum annealing principles to compress thousands of waypoints into few intelligent and interference-aware clusters. So in result, we achieve around 80% reduction in search space while keeping coverage and reliability intact. Think of it as teaching the drones not to explore every street, but only the meaningful routes. So you can notice from this figure, for example, in our work, quantum-inspired annealing helps the UAV network to avoid local suboptimal placements by using tunneling like jump mechanism. For example, you can notice that if there is a barrier in front of you, so you can just ride and the barrier and cross the barrier, right? There is no other way. However, if you apply the quantum physics and quantum inspired algorithm, they have a capacity to just cross the barrier, to pass through the barrier, to create a tunnel through a barrier by separating local optimum. So in this context, we introduce the quantum jump, which is a kind of a probabilistic event, sometimes large discrete move that allows the algorithm to instantaneously switches from one local minimum to other. So it's kind of mimicking the quantum tunneling behavior and mimics the waveform collapse as well. So that helps us to reduce the interference, improve the coordination, and have a reliable links. So this makes the drones find efficient paths very quickly and maintain the strong connections, which is not possible in existing traditional reinforcement learning schemes. So we reduce the drone decision map to around 70 to 80% by keeping the coverage quality in the desired range and then applied the reinforcement learning. So our goal is to find the reliable and low latency air networks with fewer computation. So in the end, to conclude the presentation, we can summarize in this way. So instead of exploring pass by step by step, the algorithm uses quantum-like tunneling to jump between the far apart promising regions. And this avoids unproductive, redundant local minima. So in the end, we achieve 3 times faster and smooth convergence as compared to classical k-means and SNR-based methods. and mention it's highly worthful to mention that we achieve around 77% lower outage for priority users while keeping the computational cost extremely low. So in short, drones can coordinate faster and consume less energy and deliver more reliable communication links. So to conclude this, we show that by combining quantum-inspired optimization with reinforcement learning can turn the complex air network into intelligent and self-organizing network. So we can say that when quantum meets the sky, drones won't just fly, they shall think that at the quantum speed. Thank you very much.